Hi, in the continuation of the review of the U1461 insulation resistance tester, I thought we would give it a teardown, have a look inside and see if we can identify some of the components on it. Now while we're doing that, what I thought we'd also do is actually compare it to my other two Agilent meters, which is the U1272A LCD multimeter and the U1273A, which is the OLED version of it. So between the U1273 and the 1461, really the biggest difference there is the fact that one does insulation resistance testing and the other one doesn't. To a lesser extent, the 1461 also has the 60,000 count rather than 30,000 count. So anyway, I want to just take you through that. We've already had a look inside superficially when we did the drowning test on it in the previous video, but this time I want to actually show you close-up of what's inside and see if we can identify maybe where the high voltage generation comes from and look at a few of the safety features that are built into it. So anyway, without further ado, let's get to the bench and start stripping them down. So one of the first and very obvious differences with these meters, of course, is the size. The U1273 A and the U1272A are a fraction shorter and a fraction narrower than the U1461A. The U1461 also has a slightly bigger display on it. The other difference is the U1461 has a removable rubber booty around it, whereas the 1272 and 1273, the orange booty is actually an integral part of the case, so you can't remove it or anything like that. The other parts on here is that you've got the extra connectors, of course, on the U1461 that allow you to control the high voltage testing, so it has a remote switch, whereas the U1272 and the U1273 don't have that. Aside from that, there really aren't more buttons on the display. They're arranged slightly differently, and of course you have the great big blue test button on the U1461. But aside from that, really there isn't any huge amounts of differences. Obviously the layout of the dials is different as well, because they've compressed it and relied more on the auto detection between, say, AC and DC volts, and they've made more function adjustments. The other part of this, of course, is that the U1461 does not have a high current range. So if you look at the connectors at the bottom here, you've got microamps, milliamps, and you've got volts and everything else on the other one, whereas the 1272 and 1273 have a separate high amps with a 10 amp rating. So you can only go up to 450 milliamps, which is the limit of the fuse, so really about 300 milliamps before you're going to start popping fuses or something. So that's just something to be aware of. If you want high current readings, then either you need a different meter which goes up to 10 amps, or you want to use an external current shunt, which I think I have one laying around here somewhere that I can show you. Yeah, this is one that I've had for a long time. It's a 10 amp current shunt. This one was actually from Radio Spares. I got one when I was about 17, and of course I'm not that anymore, so it just tells you how long I've had this thing. Still works quite well. It's basically a 200 milliohm shunt, so if you put 10 amps through it, you get about 200 millivolt offset, and of course in the day the typical full scale on the most accurate ranges was 200 millivolts on your multimeter too. So it has a standard pitch, so you can just plug it straight into the connector of whatever meter you happen to be using it on, and it'll give you your 10 amp range anyway. So not having it on this one, as long as you got something like this, you're set, and you can do that anyway, not a problem. So what else is there at this point? Pretty much nothing else that to note. Obviously if we turn these on, you will see one immediate difference, and that is in the display itself. Just turn these on. Aside from the fact they all have different tunes when they come on, the 1273 has a nice yellow display, basically a one row of main digits and things. The 1461 has got two ranges, so you've got your main volts range, and then you can have an alternate display underneath, which in this case is also showing volts. This is showing DC on here, and this is saying DC plus AC on the bottom one. So they could be reading slightly different with pickup on the. All right, if I put my hands near the connectors, it's picking up mains hum from my hands, so you can see the reading going up there. And then the LCD display, of course, is a little harder to see when you don't have it directly in good light, you know, unless you put the backlight on it, of course, which you can do just by pressing the button. It allows you to see it a lot easier. The LED ones, of course, are very, very readable indoors, but outside in bright light, we've already had a look in a past video, they're not quite so easy to read. You can read them. It didn't look so good on the camera, and if it's in direct sunlight, it's a bit harder, whereas the LCD one is much, much easier. Now, of course, internally in the dark or in dim light, without using the backlight on the LCD display, then these OLED displays basically leave the LCD display in the dust. So that's pretty much the external cosmetic differences. I think on the back of these things, you'll see that visually they're almost identical, obviously allowing for the difference in sizes. They all have the connector on them to allow the external connection of things like Bluetooth adapter, and it's the same Bluetooth adapter for all of them. This particular one is a one that gives you a 100-meter range, and the other one, sorry, this is the 30-meter range. The other one with the gray gray cover on it is a 30-meter range. I think I've got that the right way around. I will verify and let you know. Anyway, the U1461 actually comes with a higher range adapter for the Bluetooth. It also comes with a more complete set of probes and everything else, but right now we're looking at what's inside this thing, not what the accessories are that come with it. And there's everybody that's been reviewing this has already shown us the accessories. So I'm not going to go into that right now. Anyway, let me just grab my tools and we'll start taking these apart. So I'm going to speed the film up while I start unscrewing these. I will just fast forward it when I come time to edit, so you won't be hearing me speak much, so I'm not going to bother trying right now, but I'm just going to slowly take these things apart and let you see the stages. Now, one of the differences here is this actually has two separate compartments, one for the fuses and one for the batteries, and they're all O-ring sealed, as we've already seen. The other 2 meters, the 1272 and the 1273, both have a battery compartment, and then they have basically this clamshell lid with just the 2 screws, I think, at one end. I've never actually taken these things apart yet, so I can't guarantee exactly how much I'm going to need to do to get them into them, but we will find out. So here's the first notable difference between the 2 meters. You can see this one, which is the 1461, it's only got 1 fuse, whereas these other 2 actually have 2 fuses in the battery compartment. And the layout is slightly different. On the 1461, the low amperage fuse is in the bottom compartment here, and the one on the side is left empty, whereas on the 1172A and the 1173A, the high current fuse, it's 11 amps, is on the bottom, and the smaller 450 milliamp fuse is up the side here. So, and the batteries are in here, and in both of the 1273 and 1272, they're AAA batteries and regular alkaline, whereas in the 1461, the batteries are lithium to give us the longer life and also lower temperature operation range, because this meter is IP67 rated, and it can go down to about minus 40 degrees centigrade for operating. Now, obviously, if you took one of these into that kind of temperature with regular alkalines, the batteries would just cease functioning at that temperature. So anyway, let's continue. a little bit of shock there. There's a couple tabs right in here which click in the top, so you're actually tapping in very difficult to get. And I have a look and see, of course, but pay attention to that one. It's very similar. So just down on the side here. Just going to here. So it's the same couple tabs here for plugging in, so a couple of that one, as you can see, so far, look almost identical. We'll get into this in just a minute. Now, the final one that's really cool. So what we have is on the right hand side here we have the U1272A, which is the LCD model. In the center we've got the 1461, and on the left hand side we have the U1273, which is the OLED model. Okay, now the outer two are basically the same meter, just with one's OLED and one is LCD. So I guess there's you can see with the outer two, if I actually bring them close together just for a second, that they're pretty much on this side of the board, they're almost identical. You can see from a circuit perspective they're the same layout. The bottom here with the fusing and protection resistors and things like that pretty much the same. The circuit board, which is connecting to the banana sockets on the other side, are the same. And as we come up here, the basic circuitry looks pretty much identical. I'm just comparing layout basically at the moment of components here, and it does look almost, actually to all intents and purposes from this side, it is identical. I think the only thing I see that's really different right now is that this one has a header connected, and whereas this one just has the PCB tracks left open, so they haven't put the header on there. But outside of that, and oh, there you go, there's a slight difference. The orientation of the buzzer connection for the LCD model has been rotated by 90 degrees, and so is the capacitor. So there is a little bit of layout difference up here, but all of the main chips, without actually comparing the part numbers of all of these components, look to be pretty much identical. And really, if you think about it, so they should be, because the only difference that's happening here is the you're using an OLED display versus an LCD display. But outside of that, fundamentally, these meters are exactly the same. So I would expect all of the PCB to be the same, aside from the area that deals with the LCD display. Whereas on the U1273, whereas on the U1461, the first notable thing is we've got different methods of connecting to the PCB. On here we've only got the one fuse, and we have a large what looks like a resistor, precision resistor divider network here up down the side. We actually have this big inductor at the top here, which has been introduced that these other two don't have. This is probably associated with the high voltage generation. I'd imagine maybe there's a few diode capacitor network seems to be coming down here with this. Maybe a little bit of an oscillator circuitry or something like that would probably be used with the inductor to generate the high voltage, and maybe with some feedback to allow you to measure it. Maybe coming down here, you feeding through and back into the ADC or something like that. On the right hand side, it looks again very different. I think probably there's probably some common chips here, but I am seeing like this big quad flat pack that's in here, which is nowhere to be seen on these other two. So there's definitely been some optimizations, and definitely less chips on here, even though aside from the 10 amp range, they're fundamentally they've got a lot of the same specifications, but it looks to be a complete redesign of the board anyway. So you've got some big transistors in here, some bigger diodes and things like that, and more of them around here. You've got some spark gaps on this one on this top side for protection, and some mobs and things. Can't see them on here, but I wouldn't be surprised if they're just simply on the other side of the board. We'll have a look at that in a moment. And what else is visibly different here? Well, position of the infrared receiver transmitters is slightly different. On here it's higher up. We've still got the crystal probably driving the CPU and other functions of the board, and we've got them in a different position on each of them. And you've got your little buzzer connection and spattering of passives and everything else. So fundamentally they're the same. The board size, I think, even though the case is slightly taller, I think at this level, because we've got the rubber booty off, that's almost brought these down to pretty much the same size, give or take, I don't know, half a centimeter or something. So anyway, I guess the next thing is to pull them off the board and pull the boards out of the case and have a look at them close up on the bench without the booties on them. So let's get that done. Okay, so here we have it, the 3 meters all taken out. I haven't turned them over yet, although you may have caught a glimpse if you slowed it down as it went through. So we have the U1271, the U1273. It's actually a U1272, but it's the motherboard. The main board says U1271 on it, but of course it is a U1273, 72, which is the LCD version. So the U1271 has just got a slightly different specs and things. So anyway, it's the U1271 board, but obviously firmware and various other things. U1273 board on the left, and the 1451 board and the 1451 board in the middle. So let's turn them over one at a time so we can have a look on the other side. Okay, so let me biggest difference is here on the 1273 model. We have the current shunts are on the bottom of the board. So it's a metal bar kind. So here's the high current shunt, probably for the 10 amp range, and here it is on the 1272 as well. Basically, if you look at this area of the circuitry, here's this precision divider network that we had on the 1451, which is on the bottom of the board here, on the top should I say. We've tipped them upside down with this capacitor. And on the, well, I think it's a capacitor anyway, I'm not sure what's its designation. Yeah, it's a capacitor, it's got a C designation. And then on these two, the 1272 and the 1273, the resistor network and the capacitor is on the other side of the board, basically the top when you're looking at it normally. So what else we got here? Here's the MOVs and things and the spark gap protection for the user on the top side of the board, and the exact same layout for the 1272. The button layouts for both of them are identical, of course. So everything in this bottom area is pretty much identical between the 1272 and the 1273. When you start looking at the U1461, if I keep saying 1451, I apologize, it's 1461. So wherever you've heard me say 1451 before, I meant 61. We have a few extra high power components. So we have another one of these big TO220 surface mount devices. It's probably going to be a FET or something like that. We've got some power resistors, and we have a few more like a power diode here, and a couple more what looks like power resistors. And so yeah, the circuitry here is a little different on this one, of course, as is the method of connecting the terminals as well. These ones here have this little jumper that allows the board to detect whether the probes have been put in correctly. Actually, that's another difference I've just seen. The U1272 here only has one jumper on this connector. If I bring it up closer, here there's only one of them, whereas on the U1273 it has two of them. So probably one's going on each of the inputs. So that's a slight difference that I've just noticed there. Anything else on this side that I can see? No, I mean, aside from the fact that this one has the LCD and this one has the OLED display. I'm not going to dig deeper into those particular, I'm not going to try and take the displays off of these because I really don't want to mess up my meters. I don't have any other ones to use, so that's really as far as I'm going to take it. Looking underneath, it looks like there's just the big, I don't know if I can get a shot in there with the light or not. Maybe, I don't know. Let's see what we can do. So you can just about see in there the few components, and right in the middle here there's a large about here, and you can see it down there in the middle here, right down there. Is the large CPU probably that's driving the display and all the functionality. It's probably got the A to D converter in there and things like that. Unless the A to D converter is a separate chip. We'll have a look at what the devices are in a little bit. Anyway, so this is the OLED version. As you can see, it's there's not a huge amount to these days. There's so much integrated components and everything. I will do a close-up pass-through with them in a moment. So don't worry if I'm not doing it right this second. And then this is the 1463. So you can see here main switching and everything else, and then the OLED display on this one. So you can see the actually the main display chip is actually closer to this edge now on this one. But pretty much the same kind of devices underneath. A little header going up to the display from the board. It looks like it wouldn't be too hard actually to take that one off. Let me just check this one with the other one again. If it's put on in the same way. Oh, it is. Okay, you know what? Fair enough. I'll take off the displays. I'll just check the LCD one as for the same. So it looks like the display is almost identical on the 1273. If I compare these two, right, the back of the board is pretty much the same. The actual display though is very different. This one is the so this display is the 1461 display, and this one is the U1273A display. As you can see, it's a little bit smaller and narrower. On the back of them though, they're pretty much identical as far as the drive circuitry and everything else is concerned. So it's just power regulation and things like that. The differences in this connection to the LCD. It's actually funny, but the smaller LCD seems to have more connections than the larger one. That's probably the way it's talking to the chips that are on the LCD display, I'd imagine. Anyway, let's just put those down on the mat and we'll have a look at the board. So this is what we have left from the 1273. So this is what was underneath the display here. We've got the header for the display, a few caps, the main controls, the main controller, microprocessor, and some miscellaneous devices. So let's get the macro lens on. We'll have a look at what some of these are, and we'll have a troll through the 1461 in detail. So we're going to start off at the top of the board of the U1461 and zoom in and slowly work our way around the board here so you can see. Here we go as close as I can without trying to keep the focus. So there's the main processor chip. A D78F1168A. So I'll have to look that up. HEMLH336. It's hard to get terribly close to this without messing up the focus, because it's the macro lens. You've got to hold it so close. I don't have terribly bright light at the moment. So that's a UTC-15N06G. Should be able to see that quite clearly on the video there. Just bring it in and out of focus. So let's move out a little bit. So got that one. Just a B48 designation. So I'm not quite sure what that will be. Looks like a lot of diodes and things here, probably for driving the LCD again. Because it's roughly, well, maybe not, going down to the keyboard down here. So there's the keyboard pads. Miscellaneous transistors and things, resistors coming down the board. Now we're getting down to the bottom end near where the range switch is here. So you can see our big power transistor there, and caps, diodes, and on the other side we've got some more diodes and smaller diodes, signal diodes, and capacitors running down. Nothing on that one. And then we have this big resistor here, which is probably to do with the high voltage circuitry based on the size of these things. We just turn the board around so we can just see here. This is at the bottom. It's probably associated with the high voltage generation. So that's a IXTA3 120, X is TS1234. I have to look that up to see what that is. That's all on this side of the board. So if I now turn this over, I'll try and take some high resolution still shots as well, just to make it easier to see this. So this is the back side of the board now. We'll go up near where the high voltage generation is, which is this area here. I know this. I actually confirmed this with Keysight. Recently I was in communication with them some other things, and we were talking about these, and they actually confirmed to me that this is used for the high voltage generation for this with this transformer and this associated circuitry here. So if we just zoom in a little bit here, we'll have a look at what we've got. So that's a U128, not sure what that is, but probably associated with generating the voltage. It seems to be directly associated with this area of the board with a transformer there, or this one here, which is a B48, so I'm not too sure which ones are precisely controlling the high voltage setting. Remember, you can adjust the voltages for this thing right down to 10 volt increments, all the way up from 10 volts up to about 1000 volts. So who knows what everything is doing here without a schematic. So what we appear to have here is a diode, and yeah, these are all diodes. So we have a diode capacitor chain here. Maybe this is a voltage doubler, tripler, quadrupler, or something like that. This is part of the control circuitry, so the transformer gets it up so far, and then maybe these are doing a little bit of extra work for it to get it that last mile up to the 1000 volts. Not too sure, but it's all way away from the actual output connectors of the meter, so it's got to this high voltage has got to go all the way down the side of this board to get to the output terminal. So it's quite unusual, or I didn't expect to see it actually put way up the top of this PCB the way it is, near the top of it, versus near the output terminals. But I guess that's what Keysight decided to do with it. 6, I think. That could be the A to D converter. But I wouldn't like to guarantee it. Let's just zoom out again to get our bearings. So let's look at some of these other devices here. Yeah, the components are a little bit faint. I turn the board around for the designation. It's the other way. That's one of the chips in the middle of the board there. It's another one. Looks to be the same CMO52B, and that one is also a CMO53B, maybe a matching set of sorts. Another CMO52B, and it's go across the other side of the board here. HY313. I don't recognize the logo, but I'm sure somebody here will recognize that. Just trying to catch the light right to see if I can see the designation on these board chips. Not getting a lot of luck. Max chip. A Max 4583. That's what we have there. That's pretty much, back up to the top of the board, that's pretty much all of the significant components that are on here that we've seen so far. Like I said, I'll take a high resolution picture and try and get the part numbers and see what we can do. Going to try and do some close-up shots from here, so it's going to be a little tricky. I will try and take some static ones as well to put on the website, but for now let's just try this. So I'm just going to work our way across the board here. Just going to slowly scroll it across for the moment. I've got a completely full viewfinder here, so I'm assuming that everything is in full view. I'm going to go back again now, and I'm going to zoom in on the bottom half of the board and then slowly work my way across again. So some of these are going to be upside down. I'm not going to keep orientating the board, so I'm just working my way down. That's the transformer right there from the high voltage generation. So we're just going to slowly scroll across the board here on the bottom side so that you can see everything. That's the what looks like a diode capacitor multiplier or something like that. See if I can get the light to give away the chip part number. Just move further along. That's the switch there. We're down to the mauves. Let me back out a little bit because we've got rather big components here rather than the small ones. And we're basically at the end of the board, so see if we can move along again. Go across the middle. So that's our crystal, 9.830 probably megahertz that it's running at. That's the top of the board. So now I'm actually hitting the board right now, so let's back up a little bit. The transformer there is catching. That's the top of the board now, going back the other direction. So lots of passives and things. See if that refocuses. I don't know if it will or not. There we go. Can't get too close. and that's that big transistor TO220 case. So it's a UF840. Don't know if I can stabilize that and get the light a bit better to try and see what it says. Nope. There you go. UF840L. Lots more diodes. And down to the end of the board again. So that's pretty much the tour of that side of the board. Let me just turn this over. As I said, there really isn't much on the other side to speak of, so the only real thing that's of any consequence is this one, which is upside down. So that I believe to be the main CPU, or at least the display driver. Just back out a little bit so we can see it all. From one side to the other. So that's just the big resistors and things, and the protection circuitry and the spark gaps, etc. Lots of nice slots cut in the board to increase the creepage distances for any shorts or anything like that to protect it. Just a short part number description on the chip there, so it's not easy to tell what it is. Miscellaneous other component. So yep. Anyway, I think that's pretty much the board, what we're able to see of it anyway. I will try and take some close up with a still camera to put on the site for you. And that pretty much completes the teardown of the board. There's really not, as I say, with these modern multimeters, there's really not much to see. It is nice to see that they've Keysight has put a lot of protection circuitry into these, and you know, there's, as you can see there, there's absolutely zero adjustments. It's all done in software. And when I get a chance, I hope to be able to demonstrate how to go through the calibration procedures of this. But before I do that, I need to get myself a high resolution, high accuracy multimeter, which I don't have yet. I'm trying to find one on eBay or persuade a kind-hearted vendor to provide one to me, but we'll see what happens. Over the next few months, we'll hope for the best and see what we can get. But for now, I got my 4.5 digit U1461 and 1273 and 1272s, which do me very well, and that's it. So anyway, this is the teardown. This is completion of this video and part of the review. Next we're going to start looking at some of the functionality that's built into it. Okay, thanks. So I'll leave that I'll continue working and that ends the video. So sorry about it. And next time we'll be doing some functionality of the U1461A. We'll start with a tour of the pointy end to start with, or should I say the high voltage end anyway. As we go through here, so I'm just going to be able to hold this to try and focus on it. So these are the input terminals, as you can see. They're little clips for the sensing for when you put the remote probes on, for turning things on and off, like the high voltage or the earth leakage bondage testing and things. These are the standard connectors for the current and voltage inputs. And the other side is the negative one. Sorry, this one here is for the earth leakage bondage, where you put the remote probe to the negative side. And the one on this side, of course, is for the positive, when we do high voltage insulation resistance testing. So let's just move along a little bit. And the first thing we've got here, we've got some MOVs and some actual spark gap arresters in here for protecting the inputs. We have a massive set of diode arrays here. If I can get that to focus on the part numbers. There. Maybe they're a little upside down, perhaps. But let's just turn that around so we can get a better idea of what those parts are. Yeah, it's upside down there. Turn it around again. Just a little bit close to my camera to be able to get a good focus on everything. There. S1M D4s. Anyway, these are all diodes. Probably for input protection or, well, not sure what, but they're connected. Or what they're connected to without having to trace things out, and I'm not going to do that right now. As I said, I still haven't figured out how the high voltage is being generated on this thing, so we'll have to try and work through that and see if we can spy anything. So there's a one of the big it looks like it's using all 4 terminals, and that's the one that's sold at the top here is a just simply for a heat sink bonding, because it's got a lot of copper around that to keep it cool. So that may be just a large input protection diode, but it may be something else as well. It's either 3 terminal, because the middle terminal at the bottom is disconnected. So it's either a 2 terminal device, and we'll look that up later to see what it is. Let's just move along a little bit on the board here. Lots of little 3-4 terminal transistors and things. Trying to see anything that might, there's a little device, see if we can see what that is. It's a CMO52B. Not quite sure who or what that is yet. I'll look it up again. Yeah, CM052B. That's a Texas Instruments chip. So let's just zoom back out a little bit and move along, find some more interesting devices here to look at. So there's another TI CMO52B, and this one here is covered in a little bit of guns. I don't know if I can wipe that off. Get a better look. It's not because of any ingress or anything, it's just manufacturing crud. So that's another CMO53 in this case, not a 52. Another Texas Instruments chip. And another one. There's a larger one here. So that looks like a Max Devices 4583. And down here we got a slightly bigger chip. So we get it to focus in. An HY3131 Power MP, maybe a microprocessor of some kind, microcontroller. Again, we'll look that up. Now that I'm getting a good picture of all of these devices. So that's an AD8436. That sounds like it might be the analog to digital converter, or one of them, for the meter. And I think that's all of the major components on here. There's lots of capacitors and small miscellaneous discrete components here. The one thing that is of interest, of course, is this big transformer at the end. I didn't expect to actually see one of those, at least not at this end of the board, because as I said in one of the previous videos, this can generate 1000 volts, and I haven't actually specifically found the component that would allow it to do that. So it'd be interesting to see. That's a U128, that's a 28135. So I'm not sure what that part is. It looks like it's associated with the transformer here though. So anything else of interest down here? Just zoom out a little bit. Of course, you've got the two infrared sensors for the LEDs. And some more miscellaneous small components. Connector for the buzzer. Test connection probably. That looks like a small inductor for something, but I don't think it would be enough to be generating the high voltage, because that's 1000 volts at 1 milliamp, so that would be basically 1 watt. So I would expect something bigger to be doing that. And then the rest is just small miscellaneous components. Now if I go on the other side of this and have a look on this side, so we have these large components here. So this is the board from the other side, starting from the same end. So we're effectively looking down on the top of the board. So this will be the negative input, millivolts and milliamps. This will be the, or microamps in this case. This will be the common, and then you've got the positive and the other terminal for turning things on and off. So what we have here, which is some interesting components, are these big axial devices. I'm not quite sure what they are. They're marked as R1, R2. They're probably high voltage devices, maybe associated with the high voltage generation, and they seem to be heading towards here. So we go through here, got a diode. You can see they're actually going down to these high voltage protection devices and things. They may be associated with input protection though, not output protection. Output voltage generation. And we come across, and then we end up with another one of these largest devices. I don't know if we can get a better view to see what number that is on there. There we go, IXTA3M20. I'm not sure whose device that is, but that's a Q, so it's a transistor of sorts. Again, only two terminals at that end. It's not a diode. You've got some other, there's a diode there by the look of it, or a capacitor of some kind, but probably a diode. Nope, it's a CR, so it's probably a diode then. And some other associated circuitry. So that could be associated with high voltage generation on this side, but I don't see any coils. That's marked as a resistor, not a coil, so that's what, 1 0 1 1 black, so that's a 0. It's I'll figure out the value of that later. Can't do it off the top of my head here right now. Not the diode and things. A little bit more passive components, transistors and capacitor. So that's the switching arrangement for the input, gold plated. Some more high powered, probably half watt-ish resistors here. And lots of vias going through there for probably a higher current and low resistance drops in the path, and then back to normal kind of circuitry going up towards the LCD display there. And then these are all the contacts for the various buttons and things, and more associated transistors. Another chip there. Some of these have got some funny reflections on them. That looks like it might be analog devices. There's no number to speak of that you can get off of that. And that's pretty much it. And then we just got the OLED display, of course, at the very end here. And as I said, I'm not going to take that off. The main microprocessor is under there, but there is nothing else. So that pretty much is it. Oh, there's a few things down here. Again, more passives and things. and transistors. So rows of capacitors here, they're directly on the other side of what looks like probably a resistor divider network here. I can just get back to that in view. This one here, there's the 100K, but right next to that is this, underneath this metal can is a resistance, what looks like a resistor divider network anyway. And that's pretty much everything on this board. See if I can get some focus on what's written on the side of that. Try and move the meter up a little bit so we can, sorry, the camera. Yeah, that looks like a proprietary part or just something for the motherboard, the main board of the meter, and they've just happened to have stuck it on the side of that can. But I'm pretty sure that looks like a ceramic substrate with probably just a resistor divider network based on the connections on the other side of it there. So I don't think that's anything to do with high voltage generation, that's for sure. Anyway, that's the entire board in under my macro lens. So if you figure anything out, let me know. Get the rest put back together now.